Imagine you're building a house. If the electrician also starts doing plumbing, painting, and carpentry, the work becomes messy. If you later need to fix the electrical wiring, you risk breaking everything else. Software development works the same way. As applications grow larger, poorly organized code becomes difficult to understand, maintain, and extend. This is where the SOLID principles come in. SOLID is a collection of 5 design principles aimed at helping developers write clean, flexible, and maintainable code. Let's understand each one with a simple, real-life example. The first principle is single responsibility principle, which says that a class should have only one reason to change. In simple words, one class should perform only one job. Imagine a teacher in a school. A teacher's responsibility is to teach students. If the same teacher also manages admissions, cleans classrooms, prepares meals, and drives the school bus, it becomes impossible to manage everything efficiently. Similarly, suppose you have a class called Invoice. If it calculates the invoice amount, prints the invoice, sends emails, and saves data to the database, then it has multiple responsibilities. Whenever you need to change the email functionality, you may accidentally affect invoice calculation. A better design is to create separate classes, such as Invoice Calculator, Invoice Printer, Invoice Email Service, and Invoice Repository. Each class has only one responsibility, making the application easier to maintain and debug. The second principle is called open-closed principle, which states that software entities should be open for extension but closed for modification. This means that when you want to add new functionality, you should extend existing code instead of changing already working code. As an example, imagine an e-commerce website that calculates discounts. Initially, it supports only a regular customer discount. Later, the company introduces premium customers, festive discounts, and student discounts. If you keep modifying the same discount class every time a new discount type is introduced, you increase the risk of introducing bugs. Instead, create different discount classes like festive discount, premium discount, and student discount, all following the same interface. Now adding a new discount simply means creating another class without changing the existing code. The old code remains stable while the system continues to grow. The third principle is Liskov substitution principle, which says that a child class should be able to replace its parent class without changing the correctness of the program. In simpler terms, if one class inherits another, it should behave in a way that users expect. Consider birds. Most birds can fly, so you may create a bird class with a fly method. Then you create a sparrow class and a penguin class. The sparrow can fly, but the penguin cannot. If your application assumes every bird can fly, replacing bird with penguin will cause errors. This means penguin is not a proper substitute for bird in this design. A better approach is to create a general bird class and then create a separate flying bird class for birds that actually fly. Sparrow inherits from flying bird, while penguin inherits directly from bird without implementing fly. This way, every subclass behaves correctly, and the application remains reliable. The fourth principle is interface segregation principle, which says that clients should not be forced to depend on methods they do not use. In simple words, instead of creating one large interface with many functions, create multiple smaller and more focused interfaces. Imagine a restaurant where every employee is given the same job list: cook food, serve customers, clean tables, and manage billing. Now think about the cashier. Their job is only to handle payments. It doesn't make sense to force the cashier to learn cooking or table cleaning. Similarly, a chef shouldn't be responsible for billing customers. Instead, the restaurant creates separate roles: chef who only cooks food, waiter who only serves customers, cashier who only handles billing. Each employee only performs the tasks relevant to their role. This is exactly what the interface segregation principle says. Don't force a class to implement methods it doesn't need. The fifth and final principle is dependency inversion principle, which states that high-level modules should not depend on low-level modules. Both should depend on abstractions. This sounds complicated, but the idea is simple. Imagine you're buying a light bulb for your home. The bulb doesn't care whether it's made by Philips, Havells, or Wipro. It only needs to fit the standard socket. The socket acts as the abstraction, allowing you to replace one brand with another without changing the wiring in your house. Similarly, in software, instead of directly depending on a specific class like email service, your application depends on a notification interface. Whether the notification is sent through email, SMS, or WhatsApp can change anytime without modifying the main application. This makes the software flexible and easy to extend. Lastly, I'd like to say that most modern frameworks like Spring Boot, ASP.NET Core, Angular, and many enterprise applications are designed around these principles. If you understand Solid early in your programming journey, you'll write code that other developers can easily understand and extend, thus making you a much better software engineer. With that, I'd like to thank you for watching this video. I hope this video was helpful to you and served value. Please don't forget to like this video and subscribe to our channel for new lessons like this one.